cosine. Now, sine of a given angle is equal to opposite over the hypotenuse. And cosine of an angle was equal to the adjacent side over the hypotenuse. So sine is opposite over hypotenuse. Cosine is adjacent. So sine of a given angle is equal to the opposite side length over the hypotenuse. And cosine of a given angle is equal to the adjacent side length over the hypotenuse. And yesterday we worked on this here. We went through how to find sine and cosine given the other sides. And y'all remember doing that yesterday because we looked at the triangle and had the angle opposite over the hypotenuse, or adjacent over the hypotenuse. And then we found it as a decimal and rounded it to 4 places. And that's kind of nice and that's kind of handy, and it's really leading up to what we're going to do today, in that we're going to actually start solving for things. So sine and cosine. Now, we dealt with this yesterday because we were able to change sine of 62 degrees into cosine, because the property we saw that was sine of a given angle, sine of theta is equal to cosine of 90 minus that angle, or cosine of an angle is equal to sine of 90 minus that angle. And it works out that these work here, and they're kind of nice. But that's actually not what we're doing here. What we're doing here is we're actually finding the value of sine and cosine, because each one of these has a specific value. Now, on your calculator, the yellow calculator or white calculator that you have, I would go on and turn it on. Now, if you notice up at the very top of the screen, it says DEG, or it should, yes? Y'all see those 3 letters up at the very top? DEG. So it's right below the, actually here I gotta, why don't I get the big calculator out and show you guys this. Now this is gonna have it in the right spot. There it is. Found it. I would hang this up, but I don't have any place to hang this poster. Right here. Y'all see where it says DEG? That stands for degrees. And everything we do in this class will be in degrees. If it says RAD, you're in the wrong mode and you will not get the right answers. RAD stands for radians. It's another angle measure that we can use. And if it's in radians, it gives you the wrong value. Now, if for some reason your calculator is ever in RAD or you see that show up, all you need to do is reset it. One of the ways that we can reset it is going into the mode and changing it from degrees to radians. Or the other way is the nice little button on the back of the calculator will reset it back to degrees. And if we're wanting to find a value, so sine of 62, well, in the calculator you can hit the sine button, then 62, and then hit enter. So we'll go out to 4 decimal places, but it's a long decimal number. And we get this here. And that's it. That's the value of sine of 62. Is it 0.8829? And then rounding however we need to. How about sine of 14? Oh, 419. And that's it. How about cosine of 60? 1/2. How about cosine of 31? We kind of like these, don't we? How about cosine of 15? Divided by what? 4. What's that approximately? Turn it into a decimal. Yeah. Uh-huh. If it asks for 4 decimal places, then yes. Questions on this here? So it's going to tell us. It'll tell us around the 4 places, most likely. Now, for our answer, depending on what it is, it'll tell us, it'll specify how far out we need to go. So if we're talking about length, it's going to either say to the nearest tenths or nearest hundredths, so 1 or 2 decimal places. Angles are normally to the nearest tenth of a degree, so 1 place. So it'll specify exactly what we need. Now, kind of knowing this, well, sine or cosine of an angle is just a value. It's just a number, yes? So that means I could take cosine or sine of any angle because it gives me a number. And what we're going to do is we're going to utilize that with what we did yesterday to solve for missing side lengths. That's why sine and cosine are helpful. And we're going to look at triangles like this here. Now, they gave us one of the angles. They gave us one of the angles as 26 degrees. If we wanted to, we could find the other angle, because any 3 angles in a triangle add up to be 180. But it's not asking us to find the angle. It's asking us to find the values of x and y, the side lengths, to the nearest tenth. So 1 decimal place. Now, they gave us 26 degrees, yes? And they gave us what? They told us the hypotenuse is 14, yes? They gave us an angle, and they told us the hypotenuse is 14. Now, if I took, say, let's just use sine. So I said sine of 26 degrees. Now, this is equal to what over what? Sine is what over what? Opposite over the hypotenuse. So what is the opposite side to our angle? X. And the hypotenuse is 14. Okay. That a little better. 14. So looking at this equation here, how many variables do I have? Or unknown values do I have? 1, right? Because sine of 26, I mean, we don't necessarily know what it is. We know it has a value, yes? Sine of 26 is a number. 14 is a number. The only thing we're missing is x, yes? So if I want to find the value of x, I need to get it by its. So what do we need to do to get x by itself? We got to do something to both sides, yes? Almost. Multiply. Because x is being what currently? It's being divided by 14. So to undo the division, we have to multiply. Now, if I were to write this out, we would have 14 sine of 26 is equal to, well, 14x over 14. But we know that the 14 and 14 would cancel, leaving us with just x, yes? Okay. So I know all of you know this off the top of your head. 14 times sine of 26 is just something you have memorized, right? No. But it is easier to work with than what it has been, because it used to be that you actually had to, what you had to get was a table that actually had sine values to 4 decimal places and pull it out to reference it. But we don't have to do that anymore. We can stick this straight in the calculator. You can do 14 sine of 26. You can plug it in and hit enter. What? 1 what? 1 3, so it'd be just 6.1 because the 1 3, the 3 would round down and give us 6.1. Questions on this here? All right, now we need to find what? The value of y. We need to find the value of y. So we found the value of x as 6.1. All right, I'm going to erase this here so I have a little more space so we can still see everything and know everything is punched all up tight. So we want to find the value of y. So we can still use sine and cosine to find it, but what did I use this time? Well, how does 26 and that side length go together? Are they opposite, adjacent, or is it y the hypotenuse? It's adjacent, yes. That angle and y are adjacent. Well, which one deals with adjacent? So I can say cosine of 26 degrees is equal to whatever what? Adjacent over the y over 14. So really, when we look at these here, using sine and cosine is really going to depend on what? What we are given or what we are looking for. Any questions on this here? What would we do next? We multiply both sides by, because 14 and 14 would cancel, leaving us with y is equal to 14 cosine of 26. And at this point we can so 5, 8, which would make it 12.6. Questions on this here? Is there any way that we could have found y without using cosine? Yes. Right, because those three angles add together to be 180, yes? Now, cosine of 64 degrees. Well, cosine is what? Adjacent over the... So what's the adjacent side to 64? That'd be x, yes? Over 14. So that would give me the value of x, yes? Now, sine of 64 would have been, well, y over 14. So for some reason you dislike cosine, we could have used sine, yes? For this here. Now for any of these here, we're going to have to find at least two sides. But if I have two sides, doesn't this work? A squared plus b squared equals c squared is true if the triangle is what? It's a right triangle. Now, for the test, if you use this here, make sure to write it out so that I know that's what you're doing. Because again, when we got 6.1, what did we do? We rounded, yes? So 6.1, the exact value for x. Well, no, we had to round to get it, yes? And anytime we round and start using rounded numbers, the margin for error gets what? Bigger. So this will still work, but it's not going to be exactly right. Someone type in 12.6 squared plus 6.1 squared. And 14 squared is? So here with this rounding, we have a 0.03 error margin because of the rounding error. So for the test, I would be perfectly fine with that, using that there. But on the homework, if you try that out and see, it might work, it might not, depending on how it rounds. Does that make sense? So it might work out just fine because 0.03 with rounding isn't a big enough margin to hit. It's a small enough margin to hit. Because if it's 0.05 or greater, we round it up on tenths or round it down. So if the margin of error gets greater than 0.05, there's a chance it won't work. Does that make sense? Okay. Let's look at another one of these here. Now we have 65 degrees, and we know it's a right triangle. I just end up sticking with 65. As dealing with sine and cosine, I can end up finding the two sides. Now sine of 65 degrees is going to be what over what? It should be. Now here it's not too bad because they're asking for both, so we'll end up solving for both anyways. But really, I'm using sine of an angle if I'm given the what? The opposite and the hypotenuse. Because if I'm given those two side lengths, we're going to use sine. If I'm given the adjacent and the hypotenuse, I'm solving for cosine, yes? So sine and cosine really are helpful if I'm given opposite and the hypotenuse or adjacent and the hypotenuse. Really, we need what? For sure, we need the hypotenuse, or be looking for it. Now for sine, what do I need to do to solve this? I need to multiply both sides by 8. Because our 8 and 8 would simplify, leaving us with p is equal to 8 sine. Actually, let's do it that way. Sine of so what do we find for the value of sine of 65 times 8? Yeah? Yeah. 7.3. So when you plug this in, because I'm going to talk about this here because it's probably going to happen at some point, someone type it into the calculator exactly as I have it written, sine 65 times 8. Okay, now there's a reason I wrote this down like this here, because what the calculator is seeing is this. It's multiplying 65 by 8, that angle by 8 first, and then finding sine. Well, that's not what we want. So is it wrong to put the 8 last? No. You just got to make sure you close those parentheses. But as long as you type it in as 65, because you can edit that, what you had just typed in, put a parentheses before the 8, and it'll change it back to 7.3. So if you put a number after it, you need to make sure sine, that angle, has parentheses around it, otherwise it will give you the wrong value. Okay. What do we need to do to find u? And multiply both sides by 8. Because those two will cancel, leaving us with u is equal to So we get 8.3, but it ends up running up to 8.4. Any questions on any of this here? Any questions on anything we've done so far? We're good with these here? Yes? Okay. All right. Yeah. So looking at this here, we're going to solve for the value of x and y, given 35 degrees. Now really, when we pick sine and cosine, because again, I said this, it doesn't matter which one we do because we're finding both. But when I have to pick one or the other, what am I solving for? Am I solving for the opposite side, the adjacent, or the hypotenuse? Because if I just want to know the opposite side, I would use sine, because sine of 35 degrees is opposite over the hypotenuse. If I was just finding the adjacent, well, it'd be cosine of 35 is equal to the adjacent side over the hypotenuse. And it's just all dependent on what we're trying to find. Now, if we're solving sine first, well, the first thing I would need to do is what? Multiply both sides by 53. Because 53 and 53 would cancel out, leaving us with x is equal to 53 sine of 35. $30.39, which rounds to 30.4. Any questions on this here? Any questions on anything that we've done so far? Okay, head up. So to solve for cosine, well, we're going to do what? We'll end up doing the same thing, yes? We'll multiply both sides by 53, which will tell me y is equal to 53 cosine of 35. We have this here, and we round in the appropriate place. All right. All right. How do we feel about these here so far? We're good with these here? Yes? Yes? Okay. I'm going to skip that one and that one. So let's look at this one here. So we can use sine and cosine again. And I'm given 30 degrees, yes? So if I take cosine of 30 degrees, well, cosine's what over what? Adjacent over the... So what's the adjacent side? So the adjacent side to 30 degrees, it'd be x. Yes. So we'd have cosine of 30 degrees is equal to x over... Wait a minute, how many variables do I have this time? 2, don't I? Well, we can't solve for 2 variables at the same time. We can only solve for how many? 1. Okay. Well, let's try sine. Let's see if that's any more helpful. I'm going to write it... I wouldn't write it right below cosine. I'm going to write it right below it because I don't have space to write it over to the side. Because we're going to have to come back and solve cosine. But sine of 30 degrees is what over what? 20 over y, opposite over the hypotenuse. So what this means is that I can't solve for the adjacent side length out the gate. Because on the last few, whenever I'm given the hypotenuse, I can solve for both. It doesn't matter which one I solve for first. But if I have to solve for the hypotenuse and a side length, I'm going to have to find the hypotenuse or one of the side lengths first. In this case, I'm going to have to solve for the hypotenuse. Questions on this here? Now, when I look at this here, well, what's the first thing we need to do? I need to multiply both sides by what? Because it's helpful. Because here, just like with our numbers on the previous one, y over y is going to simplify out. And we have y, let's keep it in the same color. We'll have y sine of 30 degrees is equal to 20. And in the last problems, we can just plug this in, right? Well, can we plug this in? Is y by itself? No, it's with sine of 30, and well, sine of 30 is just a, what? A number, right? So I can multiply, divide numbers, yes? So what do I need to do to get y by itself? I have to divide both sides by sine of 30. 30, that angle, once we have it inside of sine, they are stuck together. Now, sine of 30 divided by sine of 30 is 1. We'll get y is equal to 20 divided by sine of 30 degrees. And what it'll tell us is y is equal to 40. So we can still add, subtract, multiply, and divide with these sine and cosines. But you've got to make sure we can't just divide by 30, because that 30 degrees is inside of that sine. Also, when we're looking at this here, x, y, and 20 are all what kind of measures? They are, starts with an L. 6 letters. It's lengths, right? Because they're a distance. They're a measure of length. What is 30 degrees? It's an angle, yes? Are those the same? Well, no. The only way that we can get them to be the same or kind of computationally wise is with sine and cosine. That kind of helps us to be able to convert from an angle to a length measure. So taking sine of a specific angle really helps us convert it over to a length measure so that we can actually calculate the two out. And the reason I'm saying that is because when we get down to this part, dividing by 30 won't do anything. Because 30 degrees is an angle, not a length. So we need it with that sine. When we divide by it, it has to be sine of 30. We can't just divide by 30. Now it tells us y is 40, which, okay. Y is 40. Wait a minute, because when we started this problem, we started off with cosine is equal to x over y, yes? I can, huh? Yes. Because now, I'm going to erase the whole thing, because I can replace y with 40. Now can we solve for x? Yes. And we can do that by multiplying both sides by 40. Those 40 and 40 will cancel, leaving us with x is equal to 40 cosine of 30. And x is equal to questions on this? Yeah, it's a 30, 60, 90. And the side opposite 30 is the shorter side. The hypotenuse is twice that, and the side opposite 60 is whatever the shortest length is times square root of 3. Well, that kind of worked out, yes. Questions on this here? All right, let's do another one. So again, they didn't give us the hypotenuse because the hypotenuse for this one is what? X. So we do sine and cosine. So we can look at sine of 51 degrees. And sine of 51 degrees is going to be what over what? Because opposite over the hypotenuse. So opposite side is farthest away. And the farthest side away from 51 is y. Now, cosine of 51 degrees is going to be adjacent over the hypotenuse. And the adjacent side is? The hypotenuse is x. And we know x is the hypotenuse is because it's the side opposite what? 90 degrees. Because the side opposite the 90 degrees is always going to be the hypotenuse. Now, which one would we solve for first, cosine or sine? We'll do sine or cosine. Cosine first, because it has only one variable. Now, to solve for this here, what are we going to do first? Multiply both sides by x. We're multiplying by the bottom of that fraction. Because here the x and x would cancel out, leaving us with, let's scroll down a little bit, x cosine of 51 degrees is equal to 10. Is the variable by itself? No. Okay. So what do I need to do to get the variable by itself? Of 51. You divide both sides by cosine of 51, because cosine of 51 and cosine of 51 will cancel, leaving us with x is equal to 10 divided by cosine of 51 degrees. And if we do this here in the calculator, so 8, 9, and I believe, yeah, because if they tell us to round to the nearest tenth, this would be 13 point. Okay. .9, so 15.89, I think, and then it rounds up to 0.9. Okay. Yes. So we got that there. Now we just need to find the value of y. So we got 15.9. And to get the value of y, well, we plug in the value of x. This center stage. And to get the value of y, we need to do what to both sides? And our 15.9 and 15.9 will cancel, leaving us with y is equal to 15.9 times sine of 51. Well, is the variable by itself this time? Well, yes. Plug it in. .35, which gives us 12.4. Any questions on this here? Any questions over anything we've done so far? Do we need to see how to do one more of these? Do you feel good with this here? Yes? Okay. If we feel good with this here, I will stop